I welcome you all for the session number 4 on interference of light. Learning objective of this session is interference of light, theory of interference, Young's double slit experiment. Session outcomes: interference of light, fringe width. The prerequisites for the session is concept of light, beam of light, ray of light. Okay, fringe width is the distance between the two consecutive bright or dark fringes is called as fringe width. Let D be the distance between the two slits A and B, and capital D is the distance between the screen and the plane of the slits. Let O be the point on the screen such that AO is equal to BO. The waves from A and B arrive in phase at O since they travel the same path, and hence bright band is formed at O. It is called central bright band, or also called as center of the fringe pattern. Let capital P be the point on the screen at small distance x from O as shown in figure 2. The path difference between the waves from A and B reaching the point P is BP minus AP, which is equal to lambda. Okay. From triangle BFP, BP square is equal to BF square plus FP square, which is equal to BF is nothing but a capital D, distance between the screen and the slit, D square plus FP x plus D by 2 whole square, call it as equation number 1. From triangle AEP, AP square is equal to AE square plus EP square is equal to D square plus x minus D by 2 whole square, call it as equation number 3, equation number 2. Now BP square minus AP square is equal to, it is of the form of A square minus B square, which can be written as A plus B into A minus B. Therefore BP square minus AP square is equal to BP plus AP into BP minus AP, which is equal to D square plus x plus D by 2 whole square minus D square plus of x minus D by 2 whole square. Okay, on simplification, this becomes x square plus D square by 4 plus xd minus x square minus D square by 4 plus xd, plus x square minus x square get cancelled, D square by 2 minus D square by 2 get cancelled, x plus D plus x plus D, which is equal to 2xd. Therefore, the path difference is given by delta is equal to BP minus AP is equal to 2xd divided by BP plus AP, which is equal to 2xd divided by capital D plus D, because BP is approximately equal to AP, okay, which is equal to xd by D, call it as equation number 3. For bright fringe, delta is equal to xd divided by capital D, which is equal to n lambda, call it as equation number 4. Therefore, the distance of the nth bright fringe is given by x suffix n is equal to n into capital D into lambda divided by D. Therefore, the width of the dark fringe xn minus xn minus 1, which is equal to n minus of n minus 1 into capital D divided by small d, which is equal to d lambda divided by small d, call it as equation number 5. For dark fringe, delta is equal to xd divided by d, which is equal to 2n plus 1 into lambda by 2, call it as equation number 6. Therefore, the distance of the nth dark fringe is given by xn is equal to 2n plus 1 times d lambda divided by 2d. Therefore, the width of the bright fringe xn minus of x minus n minus 1, which is equal to 2n plus 1 of minus 2 of n minus 1 plus 1 divided by d into d lambda divided by 2d, which is equal to 2n plus 1 minus 2n plus 1 times d lambda divided by 2d. Here minus 2n plus 2n get cancelled, 1 plus 1 is 2, 2 get cancelled. Therefore, you are left with d lambda divided by small d, call it as equation number 7. Equations 4 and 5 shows that the width of a dark or bright fringe is a constant and is independent of the fringe number. Therefore, the width of the bright or dark fringe is given by, it is known as fringe width and is denoted by beta. Thus, beta is equal to d lambda divided by small d. Call it is equation number 8. Here, one thing we should note that interference pattern consists of a bright and dark fringes of equal width. If white light sources are used, the fringe pattern is colored with the central bright fringe white and other fringes are colored in the order of Ubgeier. Okay, here we shall discuss some multiple choice questions on the session. The first question is fringe width is the dash. Option A, only distance between the two consecutive bright fringes. Option B, only distance between the two consecutive dark fringes. Option C, distance between the two consecutive bright or dark fringes. Option D, none of the above. We know that the fringe width is nothing but it is the distance between the two consecutive bright or dark fringes. Therefore, answer is option C, distance between the two consecutive bright or dark fringes. Second question. Two sources should continuously emit waves of same wavelength and option A frequency, option B amplitude, option C both A and B, option D none of the above. Two sources should continuously emit waves of the same wavelength and both amplitude and frequency. Therefore, answer is the option C, both A and B. Thank you for patiently listening.